So let's look at how we use our heat equation in a problem. So I have a piece of metal that's going to be dropped into water. So here's what I have. I have a piece of metal, and we said it's 10,000 grams, and it's at, what do we say, 100 degrees Celsius. And then I have a container of water, and I have 100 grams of water, and the water is at 10 degrees Celsius. All right? So that's at 10 degrees Celsius. And so what I'm going to do is I'm going to take the metal and I'm going to put it into the water, right? So I put the metal into the water, and now when the energy transfers between them, they come to equilibrium, the whole mixture is at 20 degrees Celsius. And we want to know what is the specific heat, the C, of the metal, if this is the case. So how do we do that? Well, we're going to use our heat equation. H equals mc delta T. But we're going to have to do it twice, because if we look at this, the heat, the H that was in the metal, leaves the metal, goes into the water, right? The energy goes out of the metal and into the water. That's what warms up the water from 10 to 20 degrees Celsius, right? So what we're going to have is, we're going to have the heat that comes out of, that means it's negative, of the metal, equals the heat that goes into the water. And that's going to be our key. So we're going to have to use that heat equation twice. We're going to have to use the heat equation of the metal. That's going to be the mass of the metal times the specific heat of the metal times the temperature difference of the metal. And we're going to need to figure out the heat of the water. In other words, the energy that goes into the water, by using the mass of the water, the specific heat of the water, and the temperature difference of the water. So we're going to use that equation twice in order to find the specific heat. So we're over here, remember, we're looking for the specific heat of the metal. So that's the equation we're going to use. Let's rearrange that one first. So we rearrange that one by dividing both sides by the mass of the metal and the temperature difference of the metal. Both sides, mass of the metal, delta T of the metal. So that's going to tell us that the specific heat of the metal is going to equal the heat that leaves the metal, right? And divided by the mass of the metal and the temperature difference of the metal. So I know the temperature difference, I know the mass, or I can calculate the temperature difference. We've got the two temperatures, but I don't know the heat. Remember, that's where we're going to use the water, because the heat that leaves the metal, that comes out of the metal, goes into the water. I know the mass of the water, I can look up specific heat of water, and I know the temperature difference, or I can calculate the temperature difference. So let's figure out the heat that leaves the water, or that goes into the water, rather. It comes out of the metal, goes into the water. So the mass of the water was 100 grams. We can look up the specific heat of the water, and that is 1 calorie per gram Celsius degree. And then our temperature difference, the water ends at 20 degrees Celsius, and it starts at 10 degrees Celsius. So then, let's just kind of one step at a time. 100 grams, 1 calorie per gram Celsius degree, and that is 10 Celsius degrees, because remember, that's a temperature difference. If you watch that other video, that's the way I write that. So 100 times 1 times 10 is 1,000. Grams cancels. Celsius degrees cancels. So that's 1,000 calories. So 1,000 calories is what goes into the water. But we know that 1,000 calories is what comes out of the metal. So the heat of the metal is negative 1,000 calories. So now I know the heat of the metal, and I can put that in to get my specific heat. So C, specific heat of the metal, equals the heat that left the metal, that was minus 1,000 calories, all over the mass of the metal, that was 10,000 grams, and times the temperature difference. So remember, it ended at 20 degrees Celsius, and the metal started at 100 degrees Celsius. So we're losing energy, right? The temperature's going down, and that makes sense. So the final should be lower than the initial. So that's minus 1,000 calories over 10,000 grams times, and our temperature difference is going to be negative 80 Celsius degrees. Now see, our negatives leave us. And so we have 1,000 divided by 10,000 divided by 80, and that works out to be 0.00125, and none of the units cancel. So we get calories per gram Celsius degree, which is the units of, or one of the possible units of, specific heat of the metal. So there is our specific heat of our metal.